Okay, so it says, consider the two equations below. Explain completely the similarities and differences in how you would solve each equation. Be clear and complete. Okay, this is important. You have this x here. If you're solving this equation, right, your x is in the exponent. Here, x is in your base. So for this one, you use, since the x is in the exponent, then use logs. And then x is the base, you use roots. So for this one, you want to do like log base 3 of both sides. And then those cancel and you get x. And then you do log base 3 of 12 on your calculator. So math A log base 3 of 12, get 2.261. And this one, so x is in the base, so then you do the cube root of both sides. And that undoes that, and then you get x equals the cube root of 12. And then that you do math 4. And you get 2.289. Okay, and then, oops. Alright, so it says Margie thinks she can use logs to solve 56 equals x to the 8th, since log seems to make exponents and disappear. Unfortunately, Margie is wrong. Explain the difference between equations like 2 equals 2.04x, in which you can lose logs, and 56x to 8, in which it does not make sense to use logs. Okay, so x is in the exponent. You use logs. X is in the base. Use roots. Okay, so for these ones, right, all of them, the x's are in the exponent, so we're going to use log. So we're just going to use the log with the base of the exponent. So we take the log 1.04 both sides. And then those cancel and you get x. And then you type that into your calculator. And remember, you can go like up and grab like your previous log, press enter, and then you can change the number. So 1.04 and 2. So you get 17.672. Here, the base of the exponent is 5, so we log base 5 of both sides. Those go away and you get x equals, and then again just change these numbers, right, use the delete button, $1.682. And this one, the base is 8, so you log base 8 of both sides. Those cancel, you get x. And then do log base 8 of 3. you get x equals 0.528. Okay, and then here you turn all of these into exponential equations and solve. So x to the 1 equals 25, so x equals 25. 3 to the x equals 9. 3 squared is 9, so x equals 2. 7 to the third is x. So x is 343. 3 to the 1/2 equals x. Remember, fractional exponents are types of roots, so that's the square root of 3 equals x. Or 1 point. Oops. Okay, and then here x to the third is 27. So 3 to the third, you can cube root it. The cube root of 27 is 3. Okay, it says log of 10,000 is x. So it says hint, what base does a log have automatically when no base is written? It's 10. So it's really log base 10 of 10,000. So it's x to the what is 10,000, or 10 to the x, sorry. These ones are easy, you just have to count how many zeros there are. So since there are 4 zeros, and that's 10 to the 4th is 10,000, so x equals 4. Okay, going on to the next page. It said, if 24 equals y, is it true that log of 24 equals log of y? Yes, because you can take the log of both sides as long as both the logs have the same base. Okay, it says let f of x equal root 7 minus x minus 6 and f inverse of x equal negative x plus 6 squared plus 7. So state the domain ranges of f and f inverse. If needed, restrict the domains so that their inverses are, of each other. So f of x, the domain is x is greater than 7, because if you have less than 7. So because if you have anything bigger than 7, right, you're going to get like a negative number in here, right? Like if it was 7 minus 8, that would be negative. So the domain is x is greater than 7, and the range basically, since these ones, this one's gonna look like this, so this point here is 7, negative 6. So the range is y is greater than, or so it's equal to negative 6. And then for f inverse of x, the domain and range should switch. So the domain is x is greater than or equal to -6, and the range is y is less than or equal to 7. So predict f inverse of f, then check your prediction algebraically. F inverse A should equal A, and then our check. So if you plug in like f of A, you get 7 minus A minus 6. So f inverse of f of A then would be negative root 7a minus 6 plus 6 squared plus 7. Alright, so here's our f of a going in for x here. So simplify the inside, then you get root 7 minus a squared, and then that's 7 minus a. So the squaring undoes the square root, and then that's negative 7 plus a plus 7, which is a. So that works. Alright, thanks for watching. Bye.